This meeting is being recorded.
For problem 14 from chapter 22, we're asked to show two different ways of preparing these following compounds using what's called reductive amination. So this process of reductive amination, this allows you to kind of selectively build an amine from aldehydes and ketones. So let's take a look in part A and see how we can do this and what reagents we will need to utilize. So let's start with this portion over here in our first pathway here as an aldehyde. So I'm going to draw this portion here. And then since we're breaking this CN bond here, we can also or we can rather use this as the other half of our compound in our first pathway. So we have our aldehyde. Let's apply the reagents needed. So we have acidic conditions, and then we have what's called sodium. And this is going to be a cyanoborohydride now instead of just sodium borohydride. So we have BH3CN instead of BH4. And then we're going to utilize this amine that's bonded to this six-membered ring here to complete the rest of our reaction. So we have a primary amine, again, incorporating this six-membered ring, reacting with this five-membered ring in this aldehyde here. So that's our first way of preparing this. We could work the other way where we would utilize the aldehyde that corresponds to this side of the compound. So let's start with a six-membered ring. Let's draw that aldehyde here. We'll use the same reagents. So we have acidic conditions with sodium, cyanoborohydride here. And then we'll need this half as the amine now. So now we'll have a five-membered ring bonded to a carbon there, and then that's bonded to this nitrogen. So again, we have the same reagents utilized. We just kind of break either that carbon-nitrogen bond on the left or this one on the right, and then we fill in with the corresponding aldehyde in this case. And let's see how we could do this again in part B here. So with part B, we have symmetry within our amine here that we're trying to generate. So we can do this two different ways. We need to start with a secondary amine since we have three different carbon-nitrogen bonds now. And due to the symmetry, let's start over here. We can begin with propion aldehyde here. That would be our three-membered group here. So 1, 2, 3. And then again, we'll use those same reagents. So acidic conditions with the sodium cyanoborohydride, and then just the rest of the secondary amine that we need here. So we have a methyl group up top, hydrogen over there, and then we'll orient this the same way. So we have a propyl group there. All right, so our second route would be utilizing formaldehyde for that methyl group on top. So this one-membered carbon here corresponds with that one carbon on the top of our final amine here. So we can use, again, formaldehyde now with the same reagents, sodium cyanoborohydride, and then now we're going to utilize slightly different secondary amine. Both of these groups will be propyl groups, and we'll have a hydrogen on top. And either route, you will generate that tertiary amine that was originally shown. In this last example that we'll do together here, part C, now we're going to have to start with either an aldehyde or a ketone. So depending on where we break the bond here or the bond here. So in our first route, let's begin say we break our bond above the nitrogen, we would take this path over here, where notice we have another aldehyde here as our starting material. And we do this intramolecular reductive amination here, where we could number our carbons here. So say in our final product, if this was, we number the nitrogen as 1, and then 2, 3, 4, 5, 6 going around our ring. We could compare that here. So this would be my 1, this would be 2, 3, 4, 5, and then that methyl group is on the carbon 6. So let's see how we could do that with this pathway here. So now my nitrogen's 1, 2, 3, 4, 5, 6. Notice on carbon 6 here with the carbonyl, this would actually be a ketone instead of an aldehyde now, but we still end up with that same product through reductive amination. And of course, both of these pathways, we would have utilized our acidic conditions and then our sodium cyanoborohydride.